Okay, Unit 3, Lesson 4, dividing polynomials. So we're going to learn to divide polynomials by simplifying, long division, and synthetic division. So first off, simplifying, which we've done already. So number one, basically everything on top, every number on top is divisible by 5. And we have a 5 on the bottom. So we're going to simplify and say 25 divided by 5 is 5. Now we're going to use our rules of exponents and say, right here, I have x cubed. Here I have x to the first. Where do I have more x's? On top. How many more? 2 more. The y2 here and here cancel. Y squared divided by y squared is 1. Now we're going to simplify the second term. 5 divided by 5 is 1. We don't have to put the 1, we can just go with variables, but that's okay. Actually, I lied, because in this case, we're going to need the 1, because look what happens with the x's. X to the first divided by x to the first cancels. Y squared over y squared cancels. So we actually need that 1 there to save the place. And then, negative 30 divided by 5 is negative 6. The x's are going to cancel. Y to the fourth over y squared is y squared. 4 minus 2 is 2. Or do I have more on the top? How many more? 2 more. And z to the fifth just stays. I technically can write that over 1 because it is a fraction, but since we're reducing it, we do not need it. Therefore, that is our answer simplified. 5x squared minus 1 minus 6y squared z to the fifth. We're going to do the same thing here. 18 divided by 3 is 6. M to the fifth over m cubed is m to the second. I have 2 extra m's at the top. N cubed over n to the first, n squared. Minus 12 divided by 3 is 4. M cubes cancel. N squared over n1 is simply n1. N to the first, we don't have to write the 1. And the last term, 21 divided by 3 is 7. The m cubes cancel. And I end up with n to the 6th. 7 minus 1. Final answer. Now the thing is, sometimes things aren't going to cancel. Or in this case, where we're going to now, we might be dividing by a binomial. And unless we have a matching binomial on the top, it's not going to cancel. So we need to learn how to do long division. Yes, we're going back to 4th grade long division and then bring it right back to high school with dividing polynomials. So we're going to set up the problem just like we did in grade school with our division right here. The only difference is, notice, I have an x cubed and x to the 1, but I have no x squared. So in this case, whenever you have long division, you need to put in a filler space for any missing exponents. So for example, if we had x cubed and x squared, but we didn't have x, we have to put in a 0x to save that spot. So we write 2x cubed plus 0x squared minus 4x plus 7. Now notice it says look at the first term in each and decide what numbers and variables will make them exactly the same. What that means is we're looking at this x and this 2x cubed. What do we have to multiply x by to get 2x cubed? Well, obviously, since this is 1x, we need to multiply by 2. But if we just multiply by 2, we're going to get 2x minus 4. Now we need x cubed. So if we have x to the 1, we need x squared right here. Now, just like in grade school, just like in old school long division, we're going to multiply. Remember? DMSB. Divide, multiply, subtract, bring down. So we're going to multiply. We just divided, now we're multiplying. 2x squared and now we minus this. Now you got to be careful. You got to think about this in parentheses because we're minusing a negative in there. So 2x cubed minus 2x cubed cancels. 0 x squared minus a negative is actually positive 4x squared. You got to be really careful about that. Watch the signs. Now we're going to divide again. We're back to divide. We just brought down, now we divide. I have brought down, I'm going to bring down right now. So minus 4x. Now I'm ready to divide. I'm looking at 1x again, you go into 4x squared. Obviously, 1 times 4 is 4. And x to the first times x to the first will give me x squared. So I'm going to multiply by 4x. 1x times 4x is 4x squared. Minus 8x. But remember, put in parentheses and subtract. 4x squared minus 4x squared cancels. Negative 4x minus the negative 8x is really plus 8x. So that's going to give me so I bring down the 7, and now I ask myself, what do I need to multiply by to get x to be 4x? I'm going to multiply by 4. 4 times x is 4x and negative 8. Now I want to show you another method, and you can decide what's best for you, how your brain works. Notice here it says when you subtract, change the signs, and add. You can also just make this into a negative and make this into a positive right there and add. It doesn't matter whether you do it this way or this way, whatever works for you. You can do the traditional negative and use parentheses, or you can just change the signs and add. Whatever is comfortable for you. And there's your remainder of 15. Just like we would have in grade school. We'll often have a remainder. And we'll practice plenty of these. Okay, there's an easier way to divide though. The shortcut is called synthetic division. So we're going to do the same problem. Okay? Same problem using synthetic division. So what we do is we set up the problem so the variables are in descending order, just like we did before. So we have 2x cubed, 0x squared, negative 4x, and 7. And notice it says there's a missing item, hold this top to 0. Now, take the x minus 2 and set it equal to 0 to find out what x equals. So x minus 2 equals 0, so x equals 2. That's the number we're going to be dividing by. That's going to go in this little box right here. This is how we do it. We put our number in a box. Okay? And sometimes it'll just tell you what number. If you're given that number, go for it. So set up the problem. Use only the coefficients. So here's our 2x cubed, our 0x squared, our negative 4x, and our 7, our constant. Now, we bring down the first number in the line. So we bring down the 2. We're going to need this line here. And we need space to write other numbers here. So we bring it down below the line and write the 2. Now we're going to multiply the number in the box times that number. Notice it times 2 right here. And we put a 4 right there. Then we're going to add. 0 plus 4 is 4. Now we're going to times 2 again and get 8. And add. 8 and negative 4 is 4. We're going to multiply by 2 again and get 8. 7 plus 8 is 15. And there's our answer. We're done. We just fill in the variables with one less than you started with. So notice we started with x cubed. So our answer is going to be 2x squared plus 4x plus 4, and its last number is our remainder. Now notice, we technically write it as 15 over the divisor, x minus 2. So back to this problem. This is the old school way of writing a remainder. Okay? But technically, we want to write it as 2x squared plus 4x plus 4 plus 15 over x minus 2. And if you think about it, that's really nothing new, because in grade school, if we did 7 into 29, we would say 4 times 7 is 28, get 1, and we could say 4 remainder 1. But we eventually learned that we could write it as 4 and 1/7. This number is our numerator, that number is our denominator. And we're not doing anything really different here. 15 is our remainder, it becomes our numerator, and the x minus 2 was our original denominator, so it's the denominator of our answer. So really, it's just a more advanced version of what you learn in grade school. And so here are some examples. And it's also showing you different ways they can be written. So the traditional trinomial divided by a binomial. Here is a quartic, and it looks like it's being multiplied by a binomial, doesn't it? But remember, this x to the negative 1, x plus 2 to the negative 1, means really this goes downstairs as x plus 2. And then we have, in example 3, the traditional numerator-denominator version. So let's go ahead and do these 3 both ways. So I put x minus 1 into 3x cubed minus 5x squared. Remember, plus 0x minus 2. What do I need to make 3x cubed? 3x squared. Now I'm going to multiply. 3x cubed minus 3x squared. I'm going to do the other method, change the signs and add. Cancels. Negative 2x squared. Bring down. How do I make negative 2x squared? By multiplying by negative 2x. That's going to give me negative 2x squared plus 2x. Change the signs. Add. That gives me negative 2x. Bring down negative 2. I'm going to multiply by negative 2 again to get negative 2x plus 2. So I'm going to change the signs. That gives me negative 4. And there's my answer. 3x squared minus 2x minus 2 plus negative 4 over x minus 1. Now, synthetic division. First off, I take x minus 1 and set it equal to 0. That gives me 1. So 1 is going to go in my box here. Then I'm going to write the coefficients 3, negative 5, 0, negative 2. Draw a line. Just bring down my first number and get 3. Multiply by 1. That gives me 3. I'm going to add, get negative 2. Multiply by 1, add, that gives me negative 2. Multiply by 1, add, that gives me negative 4. And suddenly there's my answer. Now remember, I started off with x cubed, so I'm going to make this into x squared, this into x, and my original divisor, and I'm done. So you can see synthetic division really is quicker. Alright, technical problems. So x plus 2 into 3x to the 4th minus 3x squared minus x plus 9. I have to see my 3, my cubed. So since I'm missing cubed, I put 0x cubed minus 3x squared minus x plus 9. So what will give me 3x to the 4th? 3x to the 3rd. I multiply. 3x to the 4th plus 6x cubed. Change the signs, cancels. Negative 6x cubed. Bring down negative 3x squared. Now what will give me negative 6x cubed? Negative 6x squared. Multiply. Multiply negative 6x squared times 2. That's going to give me negative 12x squared. Change the signs and add. Cancel. 12 minus 3 is 9x squared. Bring down. What's going to give me 9x squared? 9x. 9x squared plus 18x. Change the signs. Cancel. That's going to give me negative 19x plus 9. What will give me negative 19x? Well, negative 19. Negative 19x. Negative 19 times 2. Alright. Negative 19 times 2 is negative 38. Change the signs, add, that gives me 47, and that's my remainder. The synthetic division version of that, once again, start off with x plus 2 equals 0. That gives me x equals negative 2. So that's going to be the number that goes in the box. Now I just write my coefficients. 3, negative, no, sorry, got my 0 again. Very bad habit. There's my x cubed, my x squared, my x, and my constant. Draw my line. Negative, bring down, and I multiply. Negative 2 times 3 is negative 6. Add. Multiply by negative 2. Positive 12. 12 minus 3 is 9. Multiply by negative 2. Add. Negative 19. Multiply by negative 2. 38. Add. 47. I started off with x to the 4th. So I'm going to end up with x cubed, x squared, x, constant, remainder. If you notice that these numbers look familiar here on the second row, negative 6, 12, exactly, just in a different format. And I'm going to go to another page for number 3, just because I'm running out of room. 2x minus 1 going into 4x cubed minus 6x squared plus 4x plus 5. Now we're going to divide. 2x goes into that 2 times with the x squared. That gives me 4x cubed minus 2x squared. Change the signs, subtract or add negative 4x squared. Bring down, divide. Negative 2x will give me negative 4x squared plus 4x. Change the signs. Look at me, I'm good with numbers. This doesn't seem right. Negative 2 times negative 1 is positive 2x. Not 4x, sorry. But I change the signs, and I get 2x plus 5. And now I'm just going to multiply by 1, which will give me 2x minus 1. Change the signs. Okay, so what you end up with here is a special situation, and we don't want to actually use synthetic division when you have a fractional divisor, because otherwise you have to remember the special rule that at the end you take all your coefficients and multiply by that fraction, which would give us 2x squared minus 2x plus 1, and the remainder stays the same, which is kind of a pain to remember. So if we have a fractional divisor, we just do law division. But it can be done with synthetic division, as you see. I do wrong now.